All right, this is the lesson about lesson 3 of Unit 2, Topic 2, and we're dealing with finding slope here to begin with, but this video is really going to be about applying explicit and recursive formulas to real-life situations. So the formula you need is y sub 2 minus y sub 1 over x sub 2 minus x sub 1, which if you've seen this before, that is just the formula for finding the slope of a linear line. So this would be the first x, this would be the first y. Second x, second y. Now I can make either point the first point or the second point, it doesn't matter. But you know the x always comes before the y. So let's call this is x, this is a y, this is an x, this is a y. Let's call this the first point and this the second point. So y sub 2 would be 10. 10 minus y sub 1, which is 7, over x sub 2, which is 5, minus x sub 1, which is 3. All right, so that's going to give me an answer of 3 over 2, and that is the answer. So that means for every rise over run, so you're going up 3 for every right 2, or you're going down 3 for every left 2, depending on how you're looking at it. Now, you'll get the exact same answer if you flip this in reverse and do y2 minus y1 over x2 minus x1. All right, so y2, in fact, I'll do that right now. y2 minus y1 over x2 minus x1. So I'm going to put 4 minus 3 on top and negative 1 minus 3 on bottom. And that's going to give me 1 over negative 4, which is like going up 1, left 4. Or down 1, right 4, no matter how you want to do it. All right, so this one I'm going to do 5 minus 0 on top, negative 2 minus 0 on bottom. That means you're going up 5, left 2, or down 5, right 2. This one, y2 minus y1, y2 minus y1, so we got negative 5 minus negative 5 on top, and negative 4 minus negative 1. Lots of negatives, got to be good at your integers. So negative 5 minus negative 5 was really the same as negative 5 plus 5, which is 0. And negative 4 minus negative 1 is the same thing as negative 4 plus 1, which is negative 3. Now, this is really just a straight across horizontal line because it has a slope of nothing. It's a line that's going up nothing. It is still a function. It's not going straight up and down. Horizontal lines are still functions. It had to be vertical to be not a function. Anything over 0 would not make sense. And that's part of the reason why, they tell you can't divide anything by 0. Because, it's not a function because that just simply does not make sense. You can't divide anything by 0. All right, so this lesson is about 4 different real-life scenarios. Now, I'm going to focus on mainly the 2, this one and this one, instead of doing all 4 of them. And be ready to share out what kind of sequence do you see, what type of equation does it make it, and how does it look like a recursive and explicit function. All right, so this one is a arithmetic sequence, and I know that because this one has 3 blocks. It represents push-ups, so each block represents 1 push-up he's doing. Now, on the second day, he's doing 5 push-ups, and then he's doing 7, and then he's doing 9. So the pattern continues. That means that the pattern here is plus 2. How many push-ups does Scott do on day 10? So you can just simply continue the pattern. 5, 6, 7, 8, 9, 10. So that means he does 11, then 13, then 15, then 17, then 19, then 21. So it looks like he's doing 21 push-ups. Now, I did that by continuing the pattern, but there's got to be an easier way. How many push-ups will Scott do on day N? So, one way of doing that, which is kind of basically an explicit formula, would be started with 3 push-ups, and you multiplied that by n minus 1, and then you add the 3 push-ups. I'm sorry, no. Ignore. So let's start that back over. The pattern was 2 push-ups per day is increasing, times n minus 1 because it started on the first day, and then you've got to add the 3 push-ups that are on that first day. So 2 times n minus 1, so 2 times, let's use that to solve for 5. 5 minus 1 is 4. 4 times 2 is 8. 8 plus 3 is 11. It works. Okay, so that formula works for all of them, and 2, how did I get that? 2 was the pattern, n minus 1 because that's where it started with, and plus 3 because that was how many blocks are on the very first day. Now, I could have used any starting points, and I would just made like n minus 2, and then put a 5 over here, or n minus 3, and put a 7 over here. That would have worked. All right, so That's not the way I like to think of explicit formulas, though. I like to think of y equals mx plus b. So m is the rate of change. That's 2 times x plus the y-intercept, because that's the easiest thing to do. Boom. There it is. That equation will always work for all of these as well. Or you've got your recursive formula. F sub 1 is equal to 3 push-ups. F sub any day is equal to the previous day added by 2. All right, so now we've broken that one down. Let's break this one down also. So we've got, this is the chain email question. So 10 people are given 8 people are given on the first day. I'm going to make a table. So on the first day, 8 people are given a chain email. And then on the next day, all 8 of those people are given to give it to 10 of their friends in order to get a free ice cream bowl or something, whatever. Super bowl. It's like, yeah, super ice cream. So if 8 friends each give their chain email to 10 of their friends, that means that it's received by 80 people on the second day. On the third day, all 80 of those people are going to give it to 10 people, so that means it's going to be 800. Now you can clearly see that this is a geometric sequence, and that's the reason why I chose to do these two, because the first one was arithmetic, but this one's geometric. So how many people are going to receive it on the 7th day? Now, if you just keep that pattern going, you're going to see that this is going to be 8,000. And then on the 5th day, it's going to be 80,000. And then on the 6th day, it's, yeah, I know this is going to take a while here. So that's going to be 800,000. Yeah, that's, you know, when things go viral, things go out pretty fast. That's sort of like what you're dealing with here. So that means it looks like it's going to be 8 million people getting that chain email by the 7th day, if all 8 of those friends give it to 10 people, and that pattern keeps going. So what you're finding out here is that this is geometric sequences can get really high really fast. So it's not linear. This is an exponential function, which is a hyperbola. And you can see that after a while, it's going up really fast, really quickly. All right, so how many people are going to receive it after day 8? That'd be 8 million people. How many people will receive the email on day n? All right, so 8 people to begin with times a pattern of 10. That is the rule, to the x minus 1 power. Now, we haven't talked a whole lot about this. Why is it x minus 1 power and not x power like we've talked about in the past? Because 8 isn't the 0th term, it's the first term. Now, I could say that's the same thing as, now I don't want to write equals because I don't want to throw you off too much, but I could say, or, you could have also written 8 times 80 to the x minus 2 power, because 80 is the, whoa, did I really just do that? I'm so sorry. So let's take back, imagine, 10 seconds back. Okay, I know that was weird. So 80 times 10, because the pattern doesn't change. The pattern is going to be times 10 no matter where I start, to the x minus 2 power. Now, what changed was the starting point. I started this starting point to the second term. If I use the second term as the starting point, then I have to do x minus 2 on the outside. All right, so I'm going to skip through these other two, which are basically the same thing. You know, one's arithmetic, one's geometric. Those get a little bit more in depth. Constant difference, in this case, constant difference means it's an arithmetic sequence, and it's the number that's being added each time in a sequence of numbers. If it's not the same number, it's not a common difference. Constant difference. Common difference, constant difference, it's the same thing. So this is plus 5, then I want to make sure that looks like plus 5 again, plus 5 again, plus 5 again, plus 5 again. Here would be 28, plus 5 again would be 33, plus 5 again would be 38. All right, so the common difference here is plus 5. The recursive rule, so the first term is 3, and to find any term, you just take the previous term and you add 5 to it. If I want to find the explicit formula, I would say that in this case, f of n, I'll use function notation here. F of n is equal to a starting point, which in this case is 3, and it's linear, so we're adding 5 times the n minus 1 term. So just double check. So that's assuming that this is the first term. That's why I use 5 times n minus 1. So I'm trying to find the second term. 2 minus 1 will be 1, times 5 is 5, 5 plus 3 is 8. Okay, so that's one way of doing it. Or there's other ways. You could have used the 0th term if you want to do. So that would have been 5x, sorry. That would have been 5x plus negative 2. That would have been the exact same thing. Okay, but this one uses the first term, and this is using the 0th term. It's kind of like what I just did a second ago with that last one. Not to like bring that back in a transition, but I talked about, you know, in that geometric sequence, which was exponential, about how you don't actually have to use the 0th term. You can actually use any term you want. Common difference here. So we've got minus 2, minus 2. So it looks like we're adding negative 2. So the recursive we have here is f of 1 equals 11. F sub n is equal to f sub n minus 1 minus 2. All right, so the explicit. So for those of you that are more used to me using the 0th term, assuming that this is the first term, second term, third term, let's take it back. That means the 0 term would be 13. So you're probably used to me going something like this, negative 2x plus 13. Now, if I want to do what I did on that last question, I could also say, you know, f of n, using function notation, is equal to f, I was thinking of recursive there for a second. So the answer is equal to the starting point plus the rule, which is negative 2 times n minus 1. All right, so negative 2. So this is the second term. Negative 2 times 2 minus 1 is 1, times negative 2 is negative 2, plus 11 makes 9. Boom. I checked it. It's right. All right, as always, have any questions? Let me know. I know this lesson was a little more advanced than I had actually gone into because I had 2 other scenarios that we had not talked about. So if you get one of those in tomorrow in class, that probably means I think you're up for the challenge. So take that as, you know, as a good thing. That's a good sign. That means I think you're up to it. Okay? Thanks for watching again.